This is what the largest active volcano in the world looks like. It's so big that if it erupted tomorrow, it would cover the entire state of Florida in ash. It would also be over 1,000 times more powerful than the largest nuke ever detonated. In fact, this volcano is so scary that if it erupts, it could theoretically end all human life on Earth. Well, maybe not quite yet. This is Yellowstone National Park in the United States. And while it is the site of the largest active volcano in the world, it is highly unlikely to destroy the world anytime soon. In fact, it may even help us better understand how to predict when the world will actually end. Hello and welcome to this SCI Show video where we separate the wheat from the chaff, the signal from the noise, the fact from the fiction, to bring you the real science behind what really matters. We're here to answer the question, should I be worried about the world ending? And the answer is no. But only because a new paper out this week in the journal Science Advances has shown that the world may end slightly later than we thought. But why does everyone think it might end soon? Because of volcanoes, specifically supervolcanoes. What is a supervolcano? Well, the authors of this new paper define them as volcanoes that have had an eruption magnitude greater than 8 on the Volcanic Explosivity Index, or VEI. The VEI is a logarithmic scale where each whole number represents a tenfold increase in terms of both height of the eruption plume and volume of material ejected. So a VEI 6 eruption like Mount St. Helens in 1980 blasts out about 10 times more material than a VEI 5. An 8 is pretty huge, roughly equivalent to over 300 billion tons of TNT, which is why they can leave massive permanent scars on the landscape, and there are relatively few of these supervolcanoes around the world. As far as scientists can tell, there are only 12 that have ever had an eruption with a VEI greater than 8, and the vast majority of these happened a very long time ago. Of those 12, only 2 have had multiple eruptions of this size, and only one of those still exists and is still active today. Yellowstone. Yellowstone sits in what is known as the Yellowstone caldera, a giant crater that formed at the end of the Huckleberry Ridge eruption some 2 million years ago. Since then, the area has been home to hundreds of smaller eruptions, along with 3 enormous supereruptions that are known as the Lava Creek, Mesa Falls, and Henry's Fork events. These 3 left their own craters within the larger caldera, and collectively, with the Huckleberry Ridge eruption, mark the 4 largest eruptions in the history of the planet Earth. Together, they ejected over 400 cubic miles of ash and pumice onto the North American continent. To put that into perspective, that's enough to cover the entire state of Florida in a layer nearly a mile high. All told, Yellowstone has ejected well over 1,000 cubic miles of ash and pumice during its lifetime, and it's all thanks to a hotspot. A hotspot is a particularly feisty group of magma chambers beneath the Earth's surface, and Yellowstone sits directly above one. They don't move very often, but they do occasionally drift. As North America moves on top of it, a new volcano is born. When the North American plate moves off of it, the volcano goes dormant. In a few million years, the Pacific plate will drift over the hotspot, and a new string of supervolcano eruptions will begin. In other words, the hotspot itself isn't going anywhere. It's what's sitting on it that matters. And for now, what's sitting on it is the world's only active supervolcano. If it erupted today, it would cause all kinds of problems. Even though most of the local wildlife would probably be fine after a year or two, the bison and stuff, humans would definitely have a bad time. The surrounding areas of Wyoming, Idaho, and Montana would need to be evacuated. Ash would rain down across much of the contiguous United States, and crop failures would likely occur as far away as South America and Australia, and in the immediate aftermath, tens of thousands would die. However, this is all just for starters. The true danger of Yellowstone comes from something called the Yellowstone Decadal Timescale Volcanic Eruption. Yes, it has a real name, and yes, it's basically the apocalypse. It happens when the magma chamber beneath Yellowstone fills up and erupts. It doesn't matter whether the magma makes it all the way to the surface or gets stopped by the crust before it reaches the surface. The real damage is done by the injection of magma into the crust, which can happen at any time and without warning. Estimates suggest that the magma chamber refills every 700 years or so, and that the last refill happened in the year 1280. So by the math, we are due. The problem is that it's hard to know exactly when we are due. Like right now, it feels like we've been hearing about how dangerous Yellowstone is for the past 20 years. And that's because in 1985, researchers discovered just how close we were to being overdue. In that year, they found an ancient layer of ash dating back to the year 853 AD, just below the modern-day surface. And by studying tree rings, they found evidence of a large eruption in the year 854, which was the last time the magma chamber had filled. This sparked a lot of media coverage at the time about how we were now in the middle of a volcanic time bomb set to go off in any moment. However, further investigation revealed that the eruption hadn't reached the surface. And since then, seismologists have found many more potential eruption layers without finding any sign of an imminent supereruption. In 2020, researchers presented new evidence that suggested that instead of filling up on a regular basis, the magma chamber had undergone several periods of rapid recharge followed by slow draining. And despite the recent activity, it's still nowhere near full. So while we're definitely not in any immediate danger of a supereruption, we can't say for sure that it won't happen sometime in the next 1,000 years. And it's possible that the next supereruption could come sooner than the last one did. That's because this new paper suggests that we may have miscalculated the average timescale between the supereruptions. And since we have no idea how long a magma batch takes to drain from the system, we don't know if we're approaching the point of magma breakthrough and impending eruption. The authors wanted to figure out how quickly the magma chamber refilled after previous eruptions. So they collected data on the ages of pumice deposits from the various eruptions. Pumice is a type of igneous rock that forms when gas bubbles form in the magma and then get trapped. When the magma erupts, the pumice is blasted out of the volcano, and the oldest pumice a researcher can find, the older the eruption is dated. So the authors went to Yellowstone to try and find the oldest pumice they could. They managed to find a few specimens that date back 13,000 years, but the problem is that radiocarbon dating is only accurate for dating things up to 50,000 years old. Pumice, older than that, just falls outside of the range that the method can accurately measure. And this turned out to be a critical flaw in previous studies too. By excluding pumice older than 50,000 years, they got an average age of 43,000 for the time between eruptions. But when they included the new pumice, the average age dropped to 15,000 years. In other words, the time scale on which the magma chamber refills is closer to 15,000 years than 43,000. And if it's closer to 15,000, then we may be in trouble. Because if we're at the halfway point between eruptions, then we only have 7,500 years until we're supposed to see one. And chances are that it will happen sooner rather than later. That's the conclusion the authors came to anyway. They couldn't say for sure how fast the magma chamber is filling, but they said that their results show that it does fill up faster than we previously thought, and the next refill could indeed come in the next couple thousand years. To be absolutely clear, this paper does not say that the world is ending in any sense. It just says that it may end sooner than we thought. So, should you be worried? Probably not. But should you be paying attention? Definitely. Supervolcanic eruptions are incredibly rare, and by studying them, we can hopefully improve our ability to detect and monitor these phenomena in case one does occur. It might not help us stop it, but it may help mitigate some of the damage, and if nothing else, it can keep us from freaking out when the ground beneath our feet starts rumbling. Thanks for watching this CI Show video.